Okay, today we talk about the operational amplifier, or in short, we can call op-amp. So op-amp is an important device in the applied electronic circuit. It's an electronics device. It's a basic device. It's very important that you need to learn about op-amp when you start learning the applied electronic circuit. Okay, and it's include in many electronic circuit. Okay, for more reading, you can go to chapter 8 of our reference books. Okay, now we analyze the property of ideal amplifier. The operational amplifier usually used for amplifier. Amplifiers mean we change the magnitude of the signal, okay, to increase to enlarge the signal or to decrease the signal. Okay, so when we talk about the electronic signal, there is two things: magnitude and frequency. So to change the magnitude, we call the gain. Okay. And then we also have the frequency response. But mainly in this topic, we mainly talk for to change the gain of the signal. Okay, to change the gain of the signal. So it's the kind of something like voltage dependent source. We need to talk about the dependent voltage source, right? This is a dependent voltage source. It depends on some voltage, right? It's depends on controlled by some other source. So if we have the source, which is VR, right? Vs, whatever VR, Vs will increase by the gain A. Okay, A is the gain in this case. Output is A VR. So Vs is dependent by VR. Okay. So when we amplify, we enlarge the low level of electric signal to the larger signal. We can use this type of device, for example, in the amplifier, right? To increase my voice to louder, okay? That you change to the electronic signal, electric signal, and enlarge the signal and transfer back to the sound, for example. And this is the circuit of amplifier with some gain, it's a gain A. So in this case, if we have V here, V, for example, V in, this is the source with internal resistance, and we have the input voltage here. The output voltage will be the gain into V in, for example. Okay, this is the property of this type of device. Okay, and we also use this in many industrial device. For example, for the sensor. The sensor may be measure the strain gauge or temperature or pressure or anything into the electrical signal, right? And we get a very low signal, and we need to transmit this signal and send the signal to our controller. Sometimes we need to increase the magnitude of that signal, right? Okay, we use this type of circuit, or we call amplifier. Okay, we also need to amplify. Okay. So today we will mainly talk about the amplifier. So we have many types of amplification circuit. Okay, and basically we use op-amp. Okay, the device called op-amp. Okay. This is the ideal op amps. The op amp is the device that can change the uh, magnitude of the input signal. This is the characteristic of the op amp. Inside the device itself, whatever we in, we will get this voltage in AV in. Okay. This is the property of op amp. V in, and then we get AV in here. But the practical characteristic, when we supply V in, we may have internal resistance of the source, okay, the source resistance. For example, if this is the battery, right? If this is the battery, the battery inside may have internal resistance like this, right? RS, the RS will affect to V in, right? And then we also have the output voltage, output resistance of the op amp also. Yeah. Okay. But sometimes we can consider this value into very small value. If this value is very small, so Vs and Vl, so we can directly get Vl equal to AVS. Okay. But if we consider Rs and Rout here, so in this case, okay, we consider this loop. V in can be obtained by voltage divider. Okay. So with KVL or voltage divider, we can get the relation between V in and Vs, right? So V in will be R in divided by Rs plus R in, right? This is okay for this equation, right? Voltage divider, okay, to get V in. Okay. For VL, the output to RL, VL also can be obtained by voltage divider of this loop. Okay, that will be AV in. So AV in into RL divided by RL plus RL here. So we substitute, then we substitute V in to here. Okay, what we get is A into R in divided by Rs plus R in, and we have RL divided by R out plus RL, like this, right? This is Vs here, right? Vs here we move to here, so we get this equation. Okay. So this is the relation between VL and Vs, right? When we consider R out and Rs, right? This is the relation between when we consider R out and Rs. So if R out and Rs is negative, this will be 1, right? This will be AVS. In case if Rs and R out is going to 0, VL will be A R in by R in, RL by RL, and Vs, and then it's AVS, right? Okay. Okay. So from this equation, V in is approximately Vs. V in is approximately Vs if Rs is very small. Okay. And R in is very large value comparing to Rs. Okay. So usually R in is a very large value comparing to Rs, right? So Rs can take 0, or we take the limit of R in to infinity. If we take R in to infinity and R in by R in is 1. Okay. So this is just, we have just called, right? So this is the property of the operational amplifier. Here, this is the actual casing of the operational amplifier or op-amp. This is the type of IC, or we call integrated circuit. Okay. And usually the common op-amp, you have 8 pin. Okay. You have 8 pin. So you have done this in laboratory, right? Not yet. Okay, maybe tomorrow, right? Okay, this is quite about right time for the lecture. Okay. Okay, so the popular op-amp is the IC number 741. Okay. But I'm not sure what they use in the lab. This 741 is for the IC called operational amplifier. Okay. So the integrated circuit or IC is a type of device that includes many, inside is a circuit. There's many transistors inside. Okay, it's complex of many transistors inside this device. Okay. Okay, let's see. The symbol of op-amp. Usually we use the triangle symbol like this. Okay, this is the symbol of op-amp. Okay, and inside we have R in, and R in will be considered as a very large. This is a very large one. Okay, and we have voltage dependent source. So whatever the voltage across these two pins, we get the V out here. Okay, pass R out with the gain A. This gain we call open loop gain. Open loop gain. This gain A. AVOL, we call open loop gain, and V out will be related to V in. V in is the difference between V positive and negative. When we supply V positive to the positive pin and negative to the negative pin, we call positive pin as non-inverting input. Yeah. Non-inverting input and the inverting input. Okay, negative pin we call inverting input. Right. The plus signal, right, is non-inverting input, and the minus side we call invert the input. We invert the input. So in fact, this photo we flip the inverting input to the upper side. So this is invert, right? Inverting input is non-inverting input is positive here. So this is would be V positive and V negative. Positive and V negative. Okay. Physically, this is the op-amp. So if we have this type of device, we have 8 pin. Okay, the device with 8 pin, the IC with 8 pin. So we need to supply the power to make it work. Okay, the power supply is there. So we supply the power supply for this op-amp to positive supply and negative supply, okay, from some source, right? Okay, we need some power supply source, positive and negative. So we supply the voltage to pin number 7 and 4, like this. Okay, so therefore this is pin number 7 and this is pin number 4, right? So we supply positive and negative here, right? And then it will work. How it works is it work whatever the voltage difference between these two pins, we will get the output with the open loop gain. Okay, with the open loop gain. And the output will come out from pin number 6, right? Yeah, this pin number 6. And inverting input is pin number 2. Non-inverting input is pin number 3. Just like this. Okay. Then if we connect this device like this, we can get the circuit of operational amplifier. Okay. And the open loop gain is a very large gain. It's approximately 10 power 5 to 10 power 7. So AV open loop gain is 10 power 5 to 10 power 7. This is very large. Very large. This very large. We will get very large scale. And how to control this? If we need only 10 times input and output, we don't want this too large signal, right? We don't want too large signal. It's increased so 1 voltage into million voltage. It's too large. Okay? And this is it's impossible to use this type of signal. If we would like to use maybe 1 voltage, we would like the output 10 voltage. Okay? So the gain is 10, for example. How to control this gain? So we need to connect the op amp to some circuit. Okay? And we can control the output of the op amp. Okay. So with this large gain and our input is very large, the property of op amp is the current flow from the input side will be 0. So I in will be 0, approximately 0. We will no current flow. This is an important property that you need to keep in mind. No current flow into the output, okay, from the input side, and then no from output either, right? Just increase the voltage signal. Okay, the op amp will just increase the voltage signal. No current flow. Only power supply is there, right? Just need the power supply. Okay. This is the basic property of the op amp. Okay. Then if we connect the op amp to some circuit, then I talk about we don't need this too large signal. So how to control the relation between V out and V in, and then V out to some gain into V in. Okay, not open loop gain, right? Not A V O L, because this gain is too large. Okay, this gain is too large. So we can control the gain of the op amp by some types of circuit. So we will learn many types of circuit, okay, today. And I will include in the content only some important circuit. So if we connect the resistor RF from the output to inverting pin, okay, inverting input, inverting input, right, negative, and then we supply the voltage, and we reference non-inverting input, okay, to the reference value, okay, with this circuit. What happened to this circuit? So V positive will be 0, right? Yes, 0. V positive is 0. And IN usually is 0, right? This is the property of op amp, right? IN is 0. Yeah. So IN 0, V positive is 0. This is V negative. So if we take KCL here, KCL here, this KCL, so IS plus IF, right? We call RF, we call feedback, right? This is feedback. Source, this is feedback. IF equal to IN, and IN is 0, right? IN, sorry. So IS, what is IS? IS will be VS minus V negative divided by RS, right here. VS minus V negative, right? IS is VS minus V negative divided by RS, okay? Here. And similarly, IS will be V out minus V negative divided by RF. So here will be V out minus V negative divided by RF here and here. And V out is the open loop gain, right here. V out is AV open loop, AV open loop into input voltage and V positive minus V negative, right? And V positive is referent to V positive is 0, right? So V out is minus A open loop into V negative, and V negative, therefore V out divided by the open loop gain here. So V negative is, with this connection, V negative will be V out minus V out divided by A open loop. Yeah, right? A open loop. With this circuit. V positive is 0, right? Connect it to the reference voltage. Then from this IS equal to minus IF. Yeah. So we substitute IS and IF. So VS minus V negative divided by S equal to minus IF V out minus V negative divided by F, like this. And we also substitute here V negative by, so if we substitute V negative by minus V out, divided by A open loop, like this. Here is write substitute here. Minus V out by A open loop. This is minus V out by open loop gain, right? Like this. So we can rearrange this equation to this equation, right? Because the RS divided by VS divided by RS plus V open loop divided by these two values multiplied together. And this side, V out divided by RF and plus V RF into open loop gain, right? So we get this equation, and then we can express Vs by Rs equal to this term is minus V out by Rf minus V out by open loop gain into Rs minus V out divided by open loop gain into Rs, like this here. Okay. So Vs will be minus V out, minus V out multiply with from this. This will be Vs is minus V out, right? Here we take V out of the bracket, we get 1 plus Rf plus 1 by AV open loop Rf plus 1 by AV open loop Rs. Here Rs into Rs multiplied by Rs. To multiply by Rs is divided by Rs again, right? We can get this equation, right? To multiply by Rs is mean divided by 1 by Rs again, right? So we can get Rf by Rs again, Rf by Rs again, and Rs by Rs is cancelled. We get 1 by open loop gain here. So this is Vs, the relation between Vs and V out. So we can see that whatever Vs, V out will be in negative sign. The relation between Vs and V out is in opposite polarity. This means this is inverting because it's amplified with invert the signal. So we call this circuit as inverting amplifier. So inverting amplifier. This is a circuit called inverting amplifier. Okay, Vs and V out will have this relation, and this is A. So if a open loop is approximate to infinity, what happened to this two terms? If we consider open loop gain is very large, right? We talk about the open loop gain that is 10 million something, right? So if this is very large, if we consider these two terms will be very small, right? 0.0000. Okay, and this also 0.00 something. So we approximate these two terms to 0. Okay, to 0. So with a very large open loop gain, when a open loop approach infinity, what happens? This is 0 and this is 0. So the relation between Vs and Vout is Vs is minus Vout into 1 by Rf by Rs, or Vout is minus Rf by Rs into Vs, right? So this is basic inverting amplifier. Inverting amplifier. With the proper selection of Rf and Rs, we can get Vout in corresponding to Vs. Okay? Vout in corresponding to Vs, but it's inverse, right? Inverse, right? For example, if we have Vs, maybe 2 volt. If we have Vs 2 volt, we select Rf. For example, I select Rf 10 ohm and select Rs as 5 ohm. So what is the gain? Whatever Vs, Vout will be double, right? 10 by 5, right? Will be 2 times. We will get output increase for 2 times. But the signal is inverse, right? The signal will be inverse. So in this case, Vout will be minus 10 by 5 into 2 is minus 4, right? So we get minus 4. So this is non-inverting amp. Or if I change Rf to adjustable, right? If Rf is adjustable, if the Rs is adjustable, so I can adjust Vout, right? Okay, I can increase the volume, right, of the sound, something that we change Rf to adjustable resistance. So you take any adjustable resistance in the laboratory, right? So we can change the signal, right? But this circuit will inverse the input signal, but we can enlarge this signal. Okay, so if we take a open loop into the calculation, you can also get the similar answer. Okay, you get the similar answer, very close to this answer. So sometimes we just approximate them, right, to a large value. Okay. So this is inverting amp. Vout divided by Vs is Rf by Rs negative, right? This is the explanation of that we take, we neglect this term and this term, right? And we remain this term because A is very large. I think I explained about this already. And Vout is minus Rf by Rs into Vs. So the gain of this circuit, is minus Rf by Rs, and we call this circuit inverting amplifier. Okay, inverting amplifier. Okay. Right. And this type of connection we call negative feedback, because we connect the feedback resistance to negative pin, right, to the inverting pin, right. This is called negative feedback. Okay, this negative feedback. Okay. Negative feedback. feedback. Okay. Any question? Okay. Not so difficult, right? Just keep in your mind. I in is 0. Okay. When calculate op amp. Okay. And A open loop gain is very large. Okay. We can analyze the op amp circuit. Okay. So with the assumption that open loop gain into infinity, so V negative is V out by A open loop, right? From this analysis, from our analysis, from this. Again, if A open loop is into infinity, V negative approach to 0. So V negative approach to 0. Okay. Connect here. V out is take to reference with V positive is take the reference as V out, so V negative is approach to 0 also. Then in this case V negative and V positive is approximately equal also. So we have another property of op amp. So with negative feedback, we will get V negative equal to V positive. Okay. And also the property of op amp is I in is equal to 0 also. This two property is important for our analysis. Okay. With negative feedback. Here, negative feedback. Okay. This is a condition to calculate the operational amplifier. Okay. This condition. So under the assumption that A open loop gain approach infinity. Okay. Here. We take this assumption. We get these two property. Okay. For ideal analysis, the inverting amp closed loop gain V out here. Okay, this is our assumption, right? Op amp with negative feedback, and this is assumption with ideal op amp here. So this is two assumptions we use for our analysis here. Okay. Inverting amplifier. Invert is negative value, right? For invert. The meaning of inverse. So if we consider A with the large value, we can get different gain. So if you take A into the calculation, if the gain is, if RF by RS is 1000, but if you take A value for some large value, you will get just close to 1000, right? Not 1000, it's close to 1000. I will leave this part, okay? So I'm not going to the calculation. Okay, and also some example with the A value, right? With the open loop here. Okay, I skip this example first, and then maybe if you have time to come back. This is just to analyze the error of the resistance if we have some resistance. No, I skip this part. I think this is good. This is good example. Okay. So if we have, so this example, then we break. Okay. So if we have this circuit, so this type of circuit, and Vs is AC signal like this. Vs is this signal, the thick line. This is Vs, right? And what will we get for V out? Okay, here, right? This is Vs. And A is 0.05. A is this value, right? The amplitude of Vs, and E omega is 50 radian per second here. Rs is 1 k ohm and Rf is 10 k ohm, 1 k and 10 k. So what is the gain? This is 1 k ohm, 10 k ohm. So the gain of this circuit, ideally this will be gain of this circuit is negative 10 by 1, right? It's negative 10, right? So whatever Vs, V out will increase by 10, right? But inverse value. So in this case, for approximation calculation, so the gain will be Rf by Rs is 10 into Vs here, right? But it's invert, right? It's invert. So whatever Vs, V out will increase, right? But inverse, but in inverse signal. So this is negative. We get V out positive, right? It's increased 10 times, but it's invert. So when V in is positive, V out increase 10 times, but negative, right? Okay, so we get this signal for output. Okay, this is the op-amp property. Okay, yeah. So this part I just skip. When you analyze with the error of the resistance, when we analyze with error of the resistance, we will get what effect to the output, right? So when you use some electronic circuit, the resistance will have some error. So if we take this error, right, for 5%, for 10%, what happened? For 5%, what happened to the range of output? Okay, so I'm not going to detail this part. Okay, and then we break here and we come back with the different type of amp circuit. Okay, so you have many type of amp circuit. So we just learn one type with this inversing amp. Okay, inversing amp. Okay. So maybe we break for 5 minutes, 10 minutes. Yes, 10 minutes.